All right, what here? So anyway, here you go. So this next topic comes to us from New Atlas, and it just says Wright proposes a 100-seat electric airliner powered by
Mm.
aluminum, and then I wanted to say aluminium for everybody out there who would
Look
rather
at
me say
you.
it that way. So I know I've been corrected in the past for saying it improperly or not properly, not proper English. But there you go. So basically, what's the synopsis here? So basically, you probably got
I
it up
do.
there on the screen, but it's a U.S.-based company, Wright Electric. They do a bunch of other things. We'll get into that too. But they've proposed and are announcing a 100-seat electric short hop aircraft. It's based on the BAE
Mm-hmm.
146. So another aircraft, but a fossil fuel aircraft. They're proposing they are going to kind of retrofit this and have it be powered by
Mm.
hydrogen or a hybrid fossil fuel hydrogen kind of makeup, or this thing called an aluminum fuel cell. So we haven't talked about aluminum fuel cells on the channel before, so I'll go
No,
into
we
that a little
haven't.
bit too. But the main takeaway there is looking at either hydrogen, which we've talked about a bit before, for cars, land-based vehicles, and some of the benefits there. We talked about infrastructure for hydrogen and everything there, but looking at things like aviation, obviously, are a bit more still focused with weight on the ground, but still quite focused on how much weight you got to carry your fuels around, and that's definitely something to talk about for aviation, especially. So the main idea here is that if you're looking at hydrogen compared to like just jet fuel, hydrogen takes up a lot more space. The energy stored in the specific heat of hydrogen is
Mm-hmm.
pretty good compared to aluminum or aluminium, and also fossil fuels or jet fuel as it would be. But yeah, it takes up so much more volume, so it's not quite what they are looking for. So they are thinking about this aluminum fuel cell, and so the main, I guess, thing to maybe talk about that is looking at it. What is an aluminum fuel cell? And it's kind of like so it's not so much in the same sense as
Mm.
like a battery as it is more like a fuel cell. Like we talked about hydrogen fuel cells in the past, and in the sense that when you use a hydrogen fuel cell, it uses up the fuel of hydrogen as it being the fuel, and then you need to refuel it. Similarly to like your fossil
Mm-hmm.
fuel vehicles, whereas obviously your battery, like your Teslas and whatnot, anything uses lithium ions. It's a battery, right? Batteries, you use them and then you just plug them in, charge them,
Right. So
boom,
this
and then
one's this
that's
one's
how you
actually
that's how you
consuming.
recharge
It's
them.
consuming the actual aluminum. Right.
Yes, yeah, exactly. So, yeah, the aluminium fuel cells, in this case, and I have a few links down there if you guys are a bit interested more on the technical side of how this exactly works. And it is interesting to check out. But there's two more links down there to check that out. But basically, the idea here is that they can get still pretty good energy density or specific energy density out of the aluminium without having to do quite so much of the volume. It's better volume, obviously, than hydrogen. So that's one of the reasons they're looking at this. They are leveraging the company, Wright Electric. They're leveraging a lot of their previous expertise. They do a lot of other things, electrically based components. So they're bringing kind of the expertise, the electrical side of
Mm-hmm.
the development, while they also work on this aluminium fuel cell. So it is
Yeah.
pretty interesting, actually, to go through here and see their timeline.
I
I don't
don't
know
have
if
the
you have the
timeline up. No,
timeline
no,
up on your
I
screen
don't.
or not. I'll get it for you. Okay, cool. So technology, they're working already on their motor and inverter development. The things they're already kind of doing. That's
Mm-hmm.
2021. Next year, they're looking at their propulsion fan development. So actually, the propulsion unit. And then 2023, that's their first test of the aircraft itself with 3 engines using traditional fuels, fossil fuels, with one engine being the fully electric version of their
Mm-hmm.
test bed. So one engine, one engine. 2024, they go to 2 engines. 2025, all 4 engines on the airframe, and then 2026 they foresee bringing it to service. They have a lot of their just so you guys are kind of thinking like, where's it going to go? If this does become a thing, it's looking like they're going to be operating out of Europe for a while, out of the UK, or specifically out of
Mm-hmm.
London. It looks like that's where they have all their distances
Mm-hmm.
calculated. And again, it's a short haul. So I'll just say one more thing, then I'll pass it over to you. But so where does this kind of fit in aviation? Hydrogen, greener fuels versus traditional fuels, then versus aluminum or aluminium fuel cell. And the idea that they are basically saying is longer haul flights where the volume and the volume of hydrogen you would need to take versus the weight you need to take, it kind of balances out and is a bit more efficient for
Right.
long haul flights, hydrogen. But these short haul flights, they are saying basically they're what they've calculated, and you can see it in the article down there. They're basically saying they're getting about 1% better efficiency with on their short haul flights with this aluminum or aluminium fuel cell. So yeah, what do you think, man?
So first off, and here's the reason why Corey delivered that is because that is a complex business case on density versus duration or range versus fuel burn versus efficiency. Okay, and volume. So yeah. And what it really takes in those fuel tanks and how much space you literally get out of the aircraft, right? So there's another manufacturer, Embraer, is redesigning one of their aircraft to use hydrogen, and they say that they're putting the engines in the tail because they anticipate that hydrogen will be for longer haul flights, that it's probably going to be more beneficial to start using hydrogen, right? But this one, what really captured the imagination, so to speak, is you wouldn't think that an aluminum fuel cell would be based off of basically density per pound almost of what you're getting out of this fuel cell, right? So here's the deal, and they have it right here: the volumetric energy density, 23,277.9 versus hydrogen, which is only 2,358. That's looking at what, 10 times, right? Literally 10 times, and that's where this really comes into play. So I guess this parlays itself into why did Aviation switch to high bypass engines when they actually transferred from jets? So they went from jets, and then they went to turbofans, and then they went to turboprops, and now they went to high bypass turbofan engines. And it's always been about efficiency. Mm-hmm. And in the potential routes that they're talking about to take 100 people into some of these locales, right? And the locales also that they're looking at, they would want to exploit, say, a New York to Boston, a New York to Washington. So to give it relative towards other people understanding the marketplace, like also Atlanta to Orlando, okay? These are lucrative routes that, if given a 1% savings over time, that's how they're going to recoup their investment. Because if you keep operating a flight over and over and over again, and let's face it, some aircraft stay in service for upwards of 20 years, okay? Over time, on a daily per flight per day basis, you're saving 1% every day. That's 365% a year. And now you can go into your law of averages over 10 years, right? That's where the beauty of this plan comes in. But they've got to, it's got to work. It's really got to work. And so, brilliant plan. The problem that I see, there's only one problem that I see. You have a long-term, development plan that really needs to see that the aluminum cell technology grows at the same rate so it could be easily accessible to airport infrastructure. That's it.
Right.
That's the only thing I see that they've got to bring along with this aircraft, is that not every gate and not every airport is going to be able to service this. So you're going to at first have a very limited market. But after that, I see the potential being amazing. So.
Mm-hmm. Mm-hmm. Yeah, and actually, just talking last thing about that too, the infrastructure you just mentioned, that's something worthwhile just to have 2-second conversation on, because as we mentioned with other things, cars and obviously in this case aviation as well, the infrastructure of getting, let's say in this case, hydrogen to the airport, there are some things that need to be done there, right? It's not as easy and as in place as obviously jet fuel, because of course we're doing jet fuel now, so it's just something new. But that was one thing also that Wright proposed and was talking about in their article as well, is that the aluminum or aluminium fuel cells, and just to maybe clarify a little bit, the way the fuel cell works, it's more like kind of like a motor or an engine, in the sense that it actually uses up what you put in it. So the aluminum itself kind of acts like the fuel, and the way this is designed, it reacts with the oxygen in the fuel cell itself, and so it's actually using up the aluminum. And that being the case, when the fuel cell is used up enough of its the material in the cell, you have to actually drain that off and then recharge it physically with putting more material in the actual fuel cell. And so that would be the thing that maybe seems a little bit difficult on the face of it, but they've also said that they looked at. Basically, that recharging it is going to be aluminum, and they just have to take it to a smelter and get it resmelted, and then put in whatever form factor they need, and then transport it back to the airport or wherever it's going to be going. And they said basically the level of qualifications for the smelter they need is kind of there already. That infrastructure is kind of there, so they're not too worried about that actually. So that was one thing that as I was reading this, I was also like, okay, well, same question. Where are you going to get this fuel? And they've already kind of talked about that. So,
interesting.
Yeah, interesting.
I'd like to see what they do with this in the future. And the other thing again that I always lean on as just a closing argument for part of these discussions is look who they have as part of their development team and who they're already in bed with. Yep. And to see NASA and quite a few big Honeywell, Department of Energy. Okay. These are people that are not in obviously the U.S. Army. These are not companies that are in the business of usually just throwing money into the air and watching it burn unless they see that there's a potential there for a sale. So, very, very interesting. It's easy to pass over something like this and go, "Oh, that sounds weird," but can they really do it? And yes, I think they can, and I think they will. I think they're going to be very successful.
Yep.
So,
yeah, and that's actually, and lastly, this isn't, if you're not familiar with aluminum battery or fuel cells, they're actually being used in a lot of military projects already. That one of the third article, let's see, it's one of the articles down there below where it talks about exactly kind of the use case for aluminum batteries or fuel cells in EVs. It also mentions through what they're already, some of the things they're already using them in. And so it's something they would just take some obviously some thought, some investment to get it into aircraft. So it's not where you may not have dealt with the aluminum battery fuel cells like in your own personal life. They are already out there. The tech is already
they're not, but
so
not in our hands.
Totally,
not in our hands.
Yeah. Not for let's say general consumer use.
All right. So cool. Hope everybody got something out of that one. So.
So yeah, thanks so much for that. We're going to follow this. It's quite interesting. A little bit of a longer term project, at least for Wright aircraft, but I'll be looking at maybe aluminum fuel cells and see where else we can maybe find some information about that too. So please like, share, subscribe. Thanks so much for all the support lately. We're making some progress over the last few weeks, so thank you for that. And remember to hit that bell down there to be notified of our new show times and maybe ask us some questions on the show.
There you go. So much. All right. Well, thank you so much for that. And again, really cool technology. I can't wait to see what they're going to do with it because that sounds to me to be really profitable. Okay.